Hello, dear viewers. Welcome. Today, this is part 3 of G+4 um, RCC the design. So, we are going to do beam design in Advanced Concrete Design, that is RCDC. Before we go to RCDC, there are important things that I need to let you know. So, you should check your beams to make sure that everything is in order, because if you export your your beams to RCDC to design and your model has issues, then most of your build will fail because of minor issues. You find that, for instance, let me select this particular plan, then select object. So the first thing that is important. So let me display everything. Just do this, and let me just select event columns. So then view select objects on. Then first we will view. Okay, from here, the first thing that you should make sure that you have done correctly is the general alignment, because if you might find that in RCDC some beams are failing because of poor general arrangement. So you should make sure that your primary beams are supporting your secondary beams. So you have to be careful in general arrangement, because it is very important, and it will determine your design. So it will affect your design significantly. So you have to make sure that you do general arrangement properly, so that when you do design, your beams will not fail. So for instance, you should make sure that primary beams, secondary beams are not supported by other secondary beams, but rather by primary beams. So for instance, here in this is a veranda here. So we can see this beam is extending up to this point. It is now supported by this column and this primary beam. But if, for instance, we remove this portion of this beam, it will mean that this beam is spanning. Let's say we remove this portion there and this portion. It means that this beam is spanning all the way to this point. You can see that beam is too long to start with. And then there are other beam, secondary beam, which is supporting. So there will be a problem in general alignment here. So you have to make sure that for this beam has to extend up to this point, so that it is being supported by this column and this primary beam. Same to this one is supported by this column and this primary beam, so that this beam will be supported by this primary beam and this beam which is being supported by this. So you have to be careful. You have to visualize, to be careful with your general alignment. So that is the first point to note when you're designing beam. The other point is assigning the properties of your beam. So for secondary beam, you should release moment, because you can see that these primary beams which are supporting this secondary beam, unlike columns, they are not restrained in the longitudinal direction. So they are free to rotate in the longitudinal direction. So there should be no moments between this beam here and this beam here, right? So because if you have that moment, there will be what we call torsion, and it will lead to failure or uneconomical design. And you will find that you can have a very big cross section, but your beam is still failing, because there are moments here which you have to release. If this beam is a secondary beam, so you have to release this moment here. So for instance, you have to release moments, start and the end of this beam, because this beam, which is the primary beam, is not restrained in the longitudinal direction. But if beam is being supported by column, that is primary beam. The column is staying in a different direction, so there is no need to release moment. So there can be moments between that connection. But this connection, you have to release moment because there will be no moments there. So those are the main key points that might cause your beams to be failing. And of course, you know how you assign your moment and release. That is MZ. So mainly we release in MZ, not MX. Because if you release in MX, it means there will be failure. Okay. So release MZ in secondary beam at the starting and at the end. And some beam you can only release maybe at one point. So for instance, you release at this point and so forth and so on. So I'll go straight to advanced concrete design, that is RCDC. And before I forget, I wanted to show you also that there are two types of torsion, that is compatibility torsion and equilibrium torsion. So in my beams, let me first open RCDC. Before, because I've gone a bit ahead, so just name it anything, then I'll go to beam. I can either select all similar beams or similar floor, but I just choose first floor and then create. So I'm using VS810. So it's open. Okay, so we will first go to settings. So we have opened RCDC, Staad RCDC Connect edition. So I'll go to setting, general settings. So I want to ignore torsion, and I will ignore torsion completely. I want to ignore torsion, so I will put a high value of 30 kilometers per meter, and I will prove my point, because I think in my structure there are mainly what we call compatibility torsion. Compatibility torsion is when for instance, in this beam and this beam, which is supporting another secondary beam, there will be what we call compatibility torsion, which can be ignored. And because this beam is just simply supported, you see, so this can be ignored. But there's another type of torsion called equilibrium torsion, which cannot be ignored. So I'll just let me just show you. Just select the zoom, then zoom. So I will just select zoom. Okay, and then I'll orbit. So there is another type of torsion which is called equilibrium torsion. For instance, you can see this. There is an eccentric beam here which is not supported at the other end. So this one is called, the kind of torsion that this beam will be experiencing is called equilibrium torsion, which you have to decide. So for my structure here, I think it will be mainly equilibrium torsion, and furthermore, there are slabs which will further reduce torsion in these beams here. So that's why I want to ignore torsion almost completely. So I will put high value of 30 kilonewtons meters. And then a flange beam, I will just add all my beams are flange, and then I will go for C20 for 60. That is concrete class 20, and then I'll just use 16. And here, just I want to be uniform. And then shear, I will just use 8. There will be no need for side failure because there is no torsion. And in addition to that, my beams are all are for 50 millimeter in depth. That is smaller compared to 750 because it is smaller than 750. There is no need to design proportion because we normally design proportion if the beam depth is 750 or higher. So I just click OK. So I just want my linear spacing to be 200. Then OK for my links. Okay. And then I'll go to settings, I'll go to basic load cases, there. Okay, I will add combination for regular structure. Or you can add from the analysis, there is no difference. So from there, you can check the preferred bar spacing. I think 2 is okay. We check if it's going to pass, or we can use 3 if you want. So I think I will just use 2. Then let us design it. So we'll add our depth of slab 150. So this slab will further reduce torsion. So there's no essence of design for torsion in these things. Because if we design for torsion, there will be side-based reinforcement, which is uneconomical. Okay, so let's now run how to design. So there are 3 groups which are failing. That is group 25, group 41, and group 43. So no problem. Okay. So we'll just redesign them. So let's design this group 25. Because if you see this red, it means the group is failing, and you can see there is no detail for improvement in the top left, top mid, and top right. So I'll just maybe check which one is failing. It is 41, right? So I'll just add the top layer top to be 3, then maybe add this depth to be 500. So we'll increase the depth further to 550. So this one has passed. So just accept. We will go to another group that is being this is group 25, right? So you should note that which is group 25. Group 25. Group 25 is here. And it was being 41, which we change the dimensions to 550. So that's the dimensions here is 550. Alright, so the dimension of this being 41. So let's go back and design. So now check this, then design again. This is group 41, that is beam 70. Let's check beam 70. Beam 70, let's group 41. So beam 70 is this one. You can see it right there. So this is beam 70, this is beam 41. So we'll go to back to output, then we change this one to 450 by 50, and then add this one to 3, and then run design again, and then just accept. Then we do the same for this one, design, add 550, 3, then run, then accept. So this is beam 72. So let's check beam 72. So beam 72 is spanning all the way to that peak. I see beam 72. So this beam 70 we have changed the nature, this we have changed the nature, and also beam 41, this one here. So now everything is passed. No side plane reinforcement. If we go now to modify, let's see auto group views. So how many groups? We already have the groups, so no problem. Maybe it will depend on, let's see based on reinforcement. So this beams group 5 up to, so maybe we change group 41, the ones we just change the dimension. We can group them from just here. So this group up to no, we will not group from here. So let's go to report. We can generate a revision and section, that is drawings, then all beams, then cross-section, all beams, and then just so drawing to selection. Okay. So we want center to center. And just remove it. Move center to center. Then okay. And so we'll go to report, select, STAAD RCDC is giving very economical design. these are my so I will export. I will just save first, then save this one. I will save it in desktop folder. I will save it as beam elevations. Then I will also save. I also need to save my input. I will need to save this plan, this layout. Just beam layout. Okay. So let's go to calculations. You can just go to project settings, and or we can just go to design calculations. You can just maybe select a few groups. And just select everything. So from here you can see when it comes to SFR, web depth is less than 750. Therefore, site face reinforcement not required. So just can print this one. Beams. And also report project settings is very important because you can see everything, the materials, maximum aggregate size will be shown here, which is very important. It will decide your design, okay? So you have to be careful. So you have to print the project settings. Also indicating you have ignored torsion, value less than 30, punching all beams. So we can have this. So I will not save it. I want just print it. Then you can merge it. So remember there are some beams that we have changed dimensions. So we have to do that because now those beams will have effect on our column and our footings. So you have to change, and remember there will be similar beams in several floors. So you have to change those beams in all the floors because now that is typical design for all the floors, which have those similar beam dimension and similar beam arrangement. So I'll have to, when I close this file, I'll go and change the dimensions of the beams because I changed them here in the design. Okay, so let's generate the BPS. You can also save it, but I don't think this is necessary. So I will close this after I have saved my report, my drawing, and everything. I will save this. PDF. So let's close this. And then remember our model has changed. There are some beams which we change dimensions. So if we go to our, let's say, this beam, this beam will be similar. So we selected only, I will go plan. So I changed this here and there. So we'll go to properties. I will add define rectangular point 550 by point 2. Assign yes, close, and then we do my analysis so that we can design the columns and the foundation. Then, so I can go to view or structure. So we will do columns in part 4 of this video. So I'll just go here, go to example. Then I will come here. I will import this beam elevation and beam layout. So please skip all. We will place on them scale. So I will have to go back. Then go file interpolability match file. And of course BS5 new no, not new folder, then new elevation folder. Okay, now okay. Let's so you can see all our Maybe I can unsuspend groups, then select all my lines, then I'll change the color to black. All my text, I will change them to area. Then area and then black. Then all my dimensions, change them to black. So this one I can just make it just like this. You can see there are so many people. Maybe they are not scale. Because they are not scale. So I will just change the color to black and maybe the font to be Arial, because Arial is normally visible and then black. So maybe okay, now Arial and then black. So I can maybe select again from here. I want to just make sure everything that is not selected is now. Even this one, so I'll change this one to Arial. Then black. Okay. So we'll then import our plan, general arrangement of our bin. So I'll just go to File, Interoperability, Merge from File, then Bin Layout, open, Merge from Model, yes, open, Merge. So I just place it here, okay. So when open, I'm going to suspend groups. I'll delete all these things. Columns. Maybe I can change here to fully include and then just select all these delete. So I will let me delete these labels here. I don't need them. But maybe we'll need the labels to label these beams. So maybe we just remain with the labels. Then I will select maybe I can just copy this. Other copy. Other copy. So we will label in this copy. So I'm almost through deleting because I see now I have a copy of this. So now I will use the labels because these labels here are important. They will indicate which one is which one. Now I can be able to label in this copy property. So I will delete almost through. Delete those. I can just let me check. I can just delete like that. So I hold my shift, select all of these. Okay, delete. So there is some beam missing here. Just select it. I'll select. So I'm going to hold shift, not control. So if you hold control, you will be cutting instead of selecting. So drag a copy from this point. Yes. So I hold my shift. So I can just suspend groups. So I want all these to be aerial, then black. I can select all my dimensions. Holding my shift. So I'm going to select all of these. Then change the dimensions to black, aerial, aerial. Okay. And now select my hatch. Okay. Hold shift and select this side first. Change this one to foreground, and we just change the color. Okay. Select all my lines. Hold shift, select the other side. Change this one to black. Change to black. So now I can select my grid lines, both sides, hold shift. And I change this line type to be long dash. Okay, long dash. So we can start to label our diagram. Wait, so just maybe not maybe what I wanted. So we just leave it like that. Then we start to label our beam. So our beam starting from, I carry just one type of beam, which is this type here. Maybe I can add a fill, and I'll change it to let me show you. I change this one to then so I will use this one. That is the center, which is snapped. Yeah. So just maybe there. So I wanted to use the one in the center. So I just copy this one the outside. So this is group. This is beam. This is 150 by 450. So move, drag, copy. So I'll suspend the groups first. Suspend the groups. And then change this one. Move by drag, copy. So I'll change this one to polygon, rectangular. I change it to polygon. I just use the one because remember we are civil engineers, we are still learning ArchiCAD. So I can label it as go to documents. So this is a point. And name it 400 0.3. See that one is 400. Okay, that is too small, that's why it's looking like that. So I can just change it to 50. So for 50 by 200, then we just use X. Beam beam P. So I can just pick this one, change to black, then drag a copy. Then I'll change this one to OCR A extended. Then I can just copy, drag multiple copies. So copy the next beam. So actually you can see this beam 4. If you search here beam 4, beam 4 is somewhere. Beam 1, beam 4 is this one, beam 3 is this one, beam 2 is beam 1. So all those are just here. Then you can see them. Beam 1, 150 by 450. So next beam will be this one. So I think this one by 200. And then I'll copy. You can just go like that. So this one is actually 150. So I'll copy this one, move it, drag by move it by a copy. Then that's there. This one is 150 by 150. Beam 3 by 200 and just name it N. So just let's see which beam is that. This beam 5, 6. So we 5, 6 from here. This one. Okay, so we just copy. Drag copy. I change this one to OCR extended. Then I will drag multiple copies. So I can maybe change the size to that. Well, that is too big. Maybe change all of this. So I'll change this one to that. Okay. So I will drag multiple copies. So this one is moved is up to where? Up to beam 12. So beam 12. So up to the last one. So let's see another beam end is another. Because also support matters. So this is beam 13, beam 14, beam 15, 16, 17, 18, 19, 20, 21, 22, all the way to that. So let's go in that order. 13, where is 14? Okay, so all of these things. So that point is 16, then okay, 21, 2021, 2024, that 24, and then 25, 26, 27, 28, 29, that. After that, and then let's continue. This is the 31 up to 38, 31 up to 38. So all the 31 up to 38. Then continue up to 53, 59, so the ones changing from here, so up to 60, up to 65. So from 66 where we have some changes goes over here, so up to 65. So we about 8, that's 9, 14. Okay, 45. Mm, 61, 61, 62, 63, 64. and this one is 66, 65. Okay. And I'll select all this from here. Okay, I'll copy this one. Just move it by drag. So it's extending to be 67. 67. There is other one here. You can just need to move by dragging from there to there. Then I can move it down. Move. So this one is 66. So I'll name it. This one I'll name it beam. Beam O or beam beam M. So drag a copy. So I'm going to label this beam M. So I'm going to copy, drag a copy. Then actually here is beam N at support. So just change this one to M. So this one is beam 66. Beam M at support. This is, let's name this beam K with a depth of 550. That is 550 by 200 at support. That is at support 1. So drag a copy. So that was beam 70, beam 72, and beam 41. So we're going to label beam K, move drag a copy. Where will be that? And then home will change to OC, add the extended length, drag a copy, multiple copies. Then there is beam M. Beam M is 66. So it is 40. Beam 66. Drag multiple copies. The rest are beam N. 1 on 2, that is the M. So we have done the green. So we're going to scale everything. So I'm going to move this one just away. So sorry for that interruption. So I'm going to copy to just select everything so that I can scale. So I'm just going to go select from there. So I want to scale. So edit, the shape, the size. Okay. And then Shift D. The actual distance is 31 inch. Then hit enter. Okay. So I will change this dimension. Go to dimension settings, then marker. So I'll change it to this one. Then height. Then okay. Let's see. So dimension setting. Enter marker. So 0.5. 0.5. And pointer. Let's see. So region should be maybe 0.2. I'll change that. Then right here I will change this one to, let's say, 5. Okay. So I will pick a parameter, then inject. So hold Control and then Alt, inject. Right. So I will change my grid lines. I will select pick up arrow to the left, change it to dashes, and just pick a parameter and I'll go injecting parameter. Oops, just undo that. So I can change this line. I will use wall instead. So I will change it. I will use wall, then change this to, let's say, 12 or 18. Then change this one to 9. Change this one to polygon. Or curve. And change it to curve. So maybe we'll just do straight line. So we'll continue to add to increase the thickness of rebars. So we usually use wall, and then so I'll activate my wall too. So I will use straight line and use T. So let me try trapezoid. So remember, there were some portions which were cut out. So I'll activate my line tool and indicate these portions are actually cut out. So I'll use solid line. So I think from this point, that just double click this point is over cut out. So ArchiCAD actually here we'll add our staircase. So this portion is also cut out. This portion. And this portion. Then we will add our staircase. So actually, we will combine with the slab layout so that we'll have slab and beam layout. So I will add my staircase here. So I'll activate my staircase tool. So I'll go to design, activate my staircase. So the midpoint is about there. So just drag it. Then my landing should start from here. So just click and then return that one. Actually, it's not, it did not appear properly. So let me just do it. And at this point, just click and then landing, then going. That is the flight template. So with my arrow tool, I'll go to staircase properties. So landing, I will change to line paint black and black, light, black, red, guys. So everything black, then okay. Let's see. So actually, you can see floor plan display, and I want everything here to be black. Foreground black. So floor plan display, reflection, ceiling, also black. Foreground black. Then okay. Nothing is changing. Okay. So I will have to remove this one, move it, drag it away. Then we will copy our slab, which we did in part 2 of this video. This was our slab layout. I will move by dragging. So I'll move it up to here. So I can move my beams right on top there. Okay. Then I can just drag these ones, move by dragging. Then move by dragging. So we are going to, let me delete these which are not important. Just hold Control Select. So I'm going to delete these. Okay, so remember these beams were having their slabs, okay? So let us measure the distance. Let me activate my dimension. It's in between here and here. 600, okay. So we measure. So I'll draw another. I want to draw my slab here to indicate that this beam is flanged. So I will move this line by 600 because this is not to scale. So 150 is represented by 600. So I will just select. So maybe I can just draw. Just select, then move, drag a copy, then Shift D 600. So this indicate my slab. Okay, so I'm going to move. So I'm going to drag by copy. So this one is actually my slab. So maybe I can just mirror these labels. Move by mirror about the center there, so that they'll appear like that. And this one here, I can just select it and I need like that. Then I can just activate my wall tool. Then polygon from here. I didn't move these lines. So mirror. I will mirror even this dimension when it comes to the opposite side. I will mirror, move by mirror about that point. We can mirror dimensions. So we can. So we just like that, so we do the same thing here. Just mirror the center is already small. So just select the first one and I'll just mirror. ArchiCAD is very, you even enjoy doing your design. So architects are very privileged to have this software because it's perfect. I see the video is very long, but believe me, I'm enjoying doing this, so I don't mind whether the video will take long. So AutoCAD for me is a no-go zone. So for this, I'm going to move by 600. we drag a copy by 600. So 600 represent 150 because the drawing is not to scale. So this one is going to represent our slab. So we can actually even just dimension. Let's say from this point, one point, then okay. Okay, it's 600, and then just select it. Then let's select this. Instead of measure value, say custom text, then 150. Okay. Then so I will post the video. Just repeat everything for others, including adding this arrowhead, which is just very simple, as simple as that, and then word, and then activate polygon. Okay, it's only polygon. See this last one for polygon. So I will just that point. So I just do that, then we'll come back, then we will label this as slab layout and then beam layout. So remember, slab for cantilever, the return is longer than the bar. But for the other, the return here is a quarter of the span between of the span of that direction. Let's say it's LX, so it's 1/4/LX. So this one we did in part 2, so this one is part 3. Okay, so maybe I can just even copy this property for this staircase and inject. Just hold by Control Alt inject. So I don't know. Let me see, because remember we are learning AutoCAD, ArchiCAD, because we are used to AutoCAD. So I'm also getting familiarized myself with this software. Okay. So we forgot to check override line frame. So override line frame, override object frame, just that. So just override line frame, override object frame. So just like that. Override object attribute. Then okay. Okay, it was just do like that. Remember we did our general arrangement. You can see when I was designing my slab, you can see the general arrangement which I had done. But my general arrangement changed, but if you can see this beam here is extending. So maybe let me show you. Let me change this line to solid. Don't have let me change this line to solid. So let me first suspend groups, then just change line to solid, where the loop is similar, and then maybe copy these parameters and then inject, so that you see that when I was designing beam, I realized my general arrangement was not okay, because some of them are failing, and I knew one of the solutions is to check my general arrangement. Okay, so now you can see the general arrangement here. You can see actually this is extending. This is extending. So let me unsuspend groups. This line here, this beam is extending this point. I see a change in my general arrangement when I was designing my my slab. You can see I also have column here. I added some column. Maybe I can just copy. Maybe I just copy this, holding my sheet that, and I will copy also. Yeah. So my general arrangements changed when I was designing my build. So it is very important to note that general arrangement is very important. So even this column, I will add it. So I will just drag a copy. Ooh. I drag a copy. We will drag a copy about which point. About that point. You can see the way our general arrangement looks like now. Or we can just maybe trim some of the lines. So just control then. And also these beams are 300, this one is 200, so don't mind the way we are here. So that's how the window arrangement changed. Also this beam was not there. Maybe I should just so I will continue to inject this property. Control Alt inject. Control Alt inject. You can see the way it looks like this now will make it like. So I'll pause and finish editing here. Where I've just indicated, and then we'll come and do the file. So I will change this limit. Maybe I activate the arrow tool and just click there and click there. So I want to change the dimension stuff here. Dimension selection settings. Dimensions details. So let me first and then I change maybe here to 2. Okay. Oops, I unselected the other one, so again. Okay. So I change this to then. Okay. No problem. Maybe we can increase this scale, but it's okay the way it is. Move by traveling. Then activate my text tool. This one will be my slab layout. So I will use 20, I will use maybe 10, maybe 20. This is too big. Slab layout. This is typical first, second, third, and fourth floor slab layout. So I'll just select you, change this one to 4. Okay. So I will just select move by drag and copy. This now will be beam layout. So in the next video we will be doing foundation and column layout. So please make sure you watch the next video. That will be part 4 of this video. So I will change this one to Bondoni old style. Yeah, Bondoni old style. Let me confirm. I change Bondoni or old style. Then maybe increase the font to 20. Maybe that is too big. 6. Then this one I will maybe select both one. Wrap text and check this. Okay. So you can see how our slab and beam layout looks like. We should leave a lot of space in between. So now we can select my Q2, then print this one. I will go to File, Save As. I will change this one to PDF. Save it, slab and beam layout. change this one to A1. Then we can just change to 2. So okay, and document marquee area with page, make sure it's black and white. Then okay, so nobody is going to print colored paper. This printing is very expensive, so you have to depend on the layers to indicate or to detail what you have designed, and not the color, because nobody is going to print a colored paper. So you can see the so thanks guys. See you in the next episode, that will be column and foundation layout.